So basically, we are going to learn about, so we know enough about set, correct? We're going to talk about or review a complement of set. So complement of a set. Also, we're going to learn about if we have two sets, how do we find the intersections or complements of this? So we're going to talk about union, also intersection. Good. So there is a notation. Intersection will be like this. This is a sample of intersection. For example, we have a circle and we have a rectangle. These two intersect on this point, on this area. So it will be like A intersection by B, for example. And union will be, the notation of union is this, letter U, all right? For the same question, if we have a circle, this big circle, we have a big rectangle here, union of these two will be all of it. Good. So now let's make some example. First question. We have two sets. So when you hear about the sets, that means we are dealing with the notation like this, and there is a properties inside of this notation. Each element should be separated by comma, correct? And the number inside, or it will be in increasing order, like 1, 2, 3, 4, correct? Also, we don't repeat any element inside. I mean, you're not going to see a set like 1, 2, 2, 5. We are repeating 2 here, so this is not allowed on the set notation. So we have that information about sets. And so we have two sets. One of them is 4, 5, 6, 7, 9. Another one is 3, 6, 8, 10. They're asking us, what is A, U, B? So this U means union B. If we have, again, union means if this is A and this is B, union means all of it. Good. So the answer will be, so we're gonna have a set notation as well, okay? So when you're answering it, you need to make sure you're following all the set properties. So we're gonna have, so it's gonna be, I'm gonna write it here first. It's gonna be 4, 5, 6, 7, 9, that's A, then 3, 6, 8, 10, correct? So we need to put this one inside of the set notation, but because set has some rules, we're gonna start with the smallest one, which is 3, correct? So we're gonna have 3, then we're gonna have 4, then 5, then 6, 7. There are 2 6s here, but we get only one of them. 7, 8, 9, and 10. So this will be the answer for the A union B. For the intersection, so this notation means intersection. If this is A, that's B, intersection will be this point, this area, the area that both of them sharing. So between 4, 5, 6, 7, 9 and 3, 6, 8, 9, what do you see that they have in common?
Just 6.
Only 6, okay? I put 6. Good. So this is due tomorrow night. Let's have another one. This dealing with complements. We learn that usually we have a universe. This is going to be universe. And let's say this is A. The circle is set of A. I mean, there's a number here, 1, 2, 3. And if there's a complement, which is notation is C on the exponent, the complement will be everything not A. So complement of A will be this. I cannot be more artistic than this. It's everything not A. Good. So there are tricky questions on your homework. Complement is, I think, is due tonight. And then others is due tomorrow night and Wednesday night. So let's see how we can solve this one. This is suppose that 14 coins are tossed. Let A be the event that you get at most 6 hits. So the event A, you get at most 6 hits. That means how many, what are the options? At most 6 hits. Naz, you couldn't find a better background picture? Was kind of scary, but anyway, what is the event A? Is it at most 6 hits, correct? Can I have 7?
No.
Good. So it's going to be no hit, 0, 1, 2, 3. So it's going to be 0, 1, 2, 3, 4, 5. At most 6 hits and 6. I can include 6 as well. You get at most 6 hits. So what is the complement of this?
So X is such that X is less than or equal to 6?
That would be event A, but we are looking for complements.
Oh.
It's the
So
second one.
you are right for A, so we go opposite. So it's going to be 7, 8, 9, 10, correct? More than 6. So this will be X greater than 6.
Okay.
Correct? They said complement.
I didn't see that there. Okay.
Oh. What about this one? Suppose someone attempts to make 15 basketball shots. Let A be the event that she makes fewer than 8 shots.
It's the second one again.
So the complement gonna be more. So fewer than 8 shots. We're not including 8 shots, correct? It's gonna be 1, 2, 3, 4, 5, 6, 7. Fewer than shots. So the complement is gonna be more than. It's gonna be 8, 9, 10, 11, 12, 15. Good. Ray, are you following us? $100,000 question. Suppose that 2 6-sided dice are rolled. Let A be the event that either the first die is odd or the sum of the dice is greater than 7, or both events, both of them. Find complement of A. So in order to answer this complement, we need to find A, correct? We have to find the event A, all the set, then we subtract from whatever from the universe for all the options. So we have 2 dice, and we know that the dice are 6-sided. So we have 1, 2. So we have 1, 2, 3, 4, 5, 6 for this one, and the second one also has same, correct? Option 1, 2, 3, 4, 5, 6. So let's do the first one. They said event that either the first die is odd. So when you toss them, we're gonna have, for example, we're gonna have 1 and 3. So we're gonna write 1, 3. This is like one event. We throw them. First one is 1, second one is 3. But here they're asking us, the first die is odd. So the first one can be 1, 3, or 5. So if it's 1, we're going to have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. All of them are going to be accepted, correct? Because the first one is odd. Or we're going to have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6 also is okay because it has odd. The first one is odd. Also, we can have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. That's not acceptable as well. So we can write them. We can write 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, correct? That's event A. Then we can have 3, 1, 3, 2. You guys should love this. It takes time, but you know what you're doing, correct? Just the events. I know some of you, oh my God, who's going to write it? The maximum, we have 36 options, but they are asking us to find the complement, so it's easier. So 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, right? And also we can have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. Stephen Lee is joining us. 5, 6. So all of this 3 event, the first number here, the first die is odd. Do we have any other option that I'm not including it? No, correct. We have 1, 3, 5. So now the sum of the next one, the sum of the dice is greater than 7. When you throw them, like greater than 7, not equal to 7, we're gonna have, give you one 2 pair that you add them is more than 7.
4 and 4.
Very good. So 4 and 4 is one option, but we're gonna start. If it's okay. 4 and 4, then 4 and 5, and 4 and 6. Correct? Those gives you more than 7. Or 5 and 3, 5 and 4, 5 and 5, 5 and 6. This is more than 7 as well. Or 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. This one also gives you more than 7. Did I miss anything here?
3 and 6.
The 3s. 3, 5, and 3, 6.
3, 6 we have here.
Oh.
Okay.
Even though it's like the numbers are flipped, it's the same thing?
Same, yeah. Let's say.
Okay.
because you don't know which one is the first one. All right. So they said A gonna be this or this one, or both have occurred, or both of them. So now we want a complement of this. We don't want this set. We want something else. Agree? This is A. So the complement, first one, this blue set, all of them has odd, correct? So we're going to have the even one. We're going to have 2, 1 is not there, right? It's complement, is you don't see it here. Then we have 2, 2, good, is not listed here. This 2, 2 I wrote, it doesn't start, the first number is not odd. If you add them, you don't get 7, so it's complement. Then we have 2, 3 is okay. 2, 4 gives me 6, still is good. 2, 5 is okay as well, gives 7. Can I say 2, 6? No, it's gonna be more than 7. 2, 6 is here. Can I start with 3? No, 3 is here. All the 3s are there. The first one, 3 is there, is odd. The next one gonna be 4. 4, 1, 4, 2, 4, 3. Can I say 4, 4? No, 4, 4 is right there.
Oh,
What else can I add?
6, 1.
Very nice, 6, 1. So this is a complement of event A. I know it's too much, but that, I mean, the level of difficulty is not that complicated. It takes time to list them and then find the complements. You're not gonna have a question like this in exam, but you have a question exactly same in your homework. Okay, Rocio, are you there?
Yeah, I completed the homework already tonight. I got 100.
This was the homework for tonight?
Yeah, this one's due tonight.
Are you
The complement of set. That's what's due tonight.
And
Unless
did
you,
this?
I did it already. Yeah.
Very good. Excellent. Excellent. Okay, next question. Again, they're asking about complement here. Suppose a number is picked at random from the whole number from 1 to 18. Let A be the event that the number is both odd and less than 13. Find the complement of A. So we need to write A. So it's both odd and less than 13. So all the odd you write, 1, 3, 5, 7, 9, 11, 13. So I stop at 13, the less than 13. So this is the event A. But we want complement of this. We want something that's not in it. So we're gonna have, so we're missing 2, 4, 6, 8, 10. Then we have 12, 13, all the way to 18. I think this one is correct. The complement of set A is Musa.
Yeah.
What do you think the complement will be?
The second one, x is
Very
greater
good.
than or equal to.
Very nice. This is correct. So A is x less than equal to 7. This is 7 less than 7. The complement will be including 7 and more than 7, which is this guy. Excellent. So you answer better when your camera is not on. Good, Mushan. Okay, let's work on this one, or you guys work on this. What is A union B?
It would be all of them, right?
Very good. It will be all of them. So we have a U as a universe, 1 through 12. A will be a set of all odd numbers in U that are greater than 4. So it will be 5, 7, 9, 11, 13, 15. Somebody stopped me. No, I have 13 here. 11.
I thought it was like endless. That's why I was just gonna let you go.
No, the U is this one. That means they call it universe. All universe has only 1 to 12. Set B, the set of all numbers in U that are at most 9. So B will be 1, 2, 3, 4, 5, 6, 7, 8. At most 9. Should I include 9?
Yes, you do.
Okay, follow your rule. So what is A union by B will be, you said everything, correct, Manipur? Is that everything?
I
I
had
think
said,
Mariana.
yeah, I had said everything, but now that I'm looking at it, it's everything but 12.
Very nice. So very important. So we're gonna have, oops. We're going to have set of 1 goes to 11. You list them, correct? I just put that. What is A intersection by B?
Would it be 5?
5. A complement intersection by B. What is A complement?
All even numbers greater than 4?
1, 2, 3, 4, 6, 8, 10, and 12. Again, look at this universe. So 1, 2, 3, 4, correct? Less than is not on A. So now this set, the blue one, union by B. What do we get? We get every, because if I put 5 here, 7 there, 9 there. So we get everything, correct? Is that true? Do we get everything? Should I ask? So we get 1, 2, 3, 4, 5 in B. Then we have 6, 7 in B, 8 on A, 9 on B, 10. We don't have 11, correct? There is no 11 here. So our A, this one only missing 11. What is B complement union A? Ray, you answer this question. Looks like you're just watching a movie or something.
Mm, I'm not sure.
Okay. B complement. This is the set of B, correct? What is a complement to this set? What do we are missing here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are missing 10, 11, 12, correct? This is a B complement. Union by A. If I union this one to this set, if I add them up, we will get 5, 7, 9. We get 5, 7, 9, 10, 11, 12. Again, we need to order them in increasing order. And last one, A complement intersection by B complements, which we have these two sets right here. What do they have in common? Sierra, what do they have in common?
10 and 12. Right.
Perhaps, yes, 10 and
Okay.
12.
And I also have a question for the first one. Why does it only go up to 11? Why wouldn't we include 12?
Very good. So the first one, you're saying, why did I go 1 to 11?
Mm-hmm.
What do you think the answer should be?
Well, I was just curious as to why we didn't include 12.
I see. I think this is missing 10 also. I shouldn't, this is not correct. So let's do this one. Thanks. So we have set A, which is 5, 7, 9, 11. I get it from here. I have set B is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to union them. I'm going to add them. So basically, I start with the larger set, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, then adding 11. So 12 is not there, correct? Also 10 is not there.
Okay, thank you.
Thank you. When you're typing this in the homework, you have to make sure you're taking care of all the set properties.
For the second one on the A intersects B, so is it just one number or would it be 5, 7, and 9?
Yeah, who said 5? Manipur? Yes.
Yeah, it was me.
You're in the YouTube. Yeah. The intersection will be 5. We have 5 here. We have 7. We have 7 here. Also 9 they're sharing.
So it could be, I'm sorry. So there could be multiple. It's just not like the first same
For
number.
sure, yeah. Whatever that they are sharing.
Oh, okay.
Okay. There will be exam on this soon. The way you're taking the exam, I give you guys a couple of days, all right? Not same as a statistic. Should we do this or are you gonna do it? Let's do this one too. So that's the homework question. I think due tomorrow night. Consider the following sentence. If you roll a 6-sided die, find the probability that is not odd and is not 4. So we are finding the probability, we're finding this answer through these steps. Good. Don't try to find the probability. So this, let A be the set of odd numbers. So what is set A? Mariana, what do you think A will be?
It's gonna be 1, 3, yeah.
Yeah. So we are dealing with the die, right? What is set B? And B be the set that contains just 4.
4.
What's that?
Is it just 4 then? If it says
Just
B,
4. We don't write it just 4, just 4. Find 2 sets. So we find 2 sets. Number 2, the set not odd numbers is complement of A. Find complement of A. What is complement of A?
two, 4, and 6.
2, 4, and 6. So our universe or U will be set of 1, 2, 3, 4, 5, 6. Where did I get this one? From a die. Correct? There's 6 sides, that's a number. What about not a 4? What's the complement of B? Let's ask Ray. Ray, what's the complement of B?
1, 2, 3, 5, and 6.
You just broke my. Yes, it will be 1, 2, 3, 5, and 6. We are missing 4. Now, what is A complement intersection by B complement? So this is the answer for the probability. What is A complement is here. That's the set. What is B complement? That's here. What is intersection?
2 and 6.
2 and 6. So that's the set. If you bring 2 or you bring 6. But that's a set of numbers which is not odd and is not 4. Wow, I have 3 more questions. Okay, let's do this. That's the homework due tomorrow night, guys. You guys can save a lot of time and put it on the statistic part, chapter 5. Let A be the set of the number of units that represents more than 3. So more than 3, in your homework, there is a ... here. That means you don't need to make it as x such as x greater than 3. So don't do this because you're going to get the wrong answer. More than 3 will be 4, 5, 6, 7, and ... All right. So this will be solution for part A, for the set A. Number 2, let B be the set of numbers of units that represent less than 14 units.
Would it be 1 to 13?
Adrienne, 1, 2. So B be the set of number of units that represent less than 14.
Yeah, like 1 to 13.
Very
just
good.
like
Yeah, I know what you're saying. But so 1, 2, 3, 4 goes to
13.
Would it be 4 to 13?
I think at the end gonna be 4 to 13 because the student is taking more than 3 units and less than 14 units. So we have a minimum value here, 3.
Mm.
Correct? So we're gonna start with the 4. With 3. So let be the set of the numbers of units that represent less than 14 units. So it can be 3, 4, 5, till 13.
All right.
All right. So you are right if we didn't have this information. So we are dealing with the unit, number of units for the students.
All right. Thank you.
Very good, Elia. So what about 3, A intersection by B? If we intersect, what do we get? So this is a correct answer. So this is not correct. So here they're saying let B be set of number represent less than 14 units.
So
All
the
right, it's gonna be
information
1
above,
to 13.
so the information about more than 3 units doesn't.
No, they
need to be
didn't say that.
added.
No, the way they questioned it confused me. That's why I went to see the solution. So this set B is nothing to do with this. But at the end, then whatever we find, that would be the solution for this guy. Correct? To find the desired set, find the intersection A and B, will be 4 to 13, which is exactly they're saying here. The student is taking more than 3 units and less than 14. More than 3 units, which is 4, less than 14 units, which is 13. Correct? So this 1, 2, 3 is walking us through to get the answer. Cool? Mariana? Good. Let's do this. Consider the following sentence. When the probability that this household has fewer than 6 windows or has 13 windows. So fewer than 6 windows, what is the set?
1 through 5, right?
Fewer
1,
than
3.
6 windows. So it's going to be 0, 1, 2, 3, 4, 5. Good. We will have no window, 1 window, 2 window. Set B has 13 windows. What is B?
Just 13.
It will be just 13. Very good. So this will be 13. What is A union B?
Would it be the 0 through 5, comma, then 13? Can we do that or no?
Say again.
Would it be 0 through 5 from set A and then comma 13? Can we do that?
What's wrong with this? We have,
I don't know, I'm asking.
yeah, this is a set. I mean, we're not repeating any number inside, and there's an increasing order.
Okay.
So there's nothing wrong with the set property. And what we have here is exactly what they're saying here. Fewer than 6 windows or has 13 windows. This is fewer than 6 windows or 13 windows. So basically they're teaching us how to find the answer. Tell me what is.
I'm sorry, can you go back to the previous question really quick? So that was the answer, what Mariana said? For the last question, number 3?
Yes. What do you think the answer should be?
No, I just didn't know what the answer would be.
No. So set A, we are okay to set fewer than 6 windows. We don't want to go to negative number. We're going to start with nose window, which will be 0. The maximum will be 5, correct? Set B, they said, has 13 window, only 13, correct?
Correct.
Right. So now if you apply union to this, what do we get? A union B. That means we're going to start with set A, which is 0, 1, 2, 3, 4, 5. Then we're going to add set B, which is 13.
Okay. Thank you.
So, let's see who's going to answer this question. So set S be the universal set. So this is our universe. So we have a universe here. 1, 2, 3, goes to 20. Set A is that, set B is that. What is A union by B? Adrienne?
Yes, Professor. Oh, I was just solving it,
Oh, good.
making the
Okay.
circles. Sorry.
Jaden. Jaden, what's the answer? Jaden is Sierra. Lizzie. Are you guys there or just sleeping?
Here, I'm just,
We're here.
I don't
Okay,
know.
that's good to know you guys there. Breathing. Naz? Musa. I know you're there.
I don't know. I don't.
The question is, are you there or not? So I give you.
I am here, but I just don't know.
So we know set A is 1, this, and 1, 2, 7. B. This is a union, so we're gonna collect them, combine, put everything all all the numbers in one set, but we don't want to repeat. You're gonna have 1, 2, so 1 is gone. Then we have 2, then we have 3. The next number is 5, then is 7, then is 8, 11 gone, then we have 13, then we have 14, then we have 15, then we have 16. You have to erase this guy, comma 19. Correct? That's how we find the union. Another question is, what is the intersection? Intersection, wow, I don't know what is A right now. So did you guys copy this?
1 and 11?
So now I cannot read the number because I crossed them. So I'm gonna go back. So intersection will be 1, they have, then we have 11. So just don't put 1 because all 1 and 11 has 1 in it. No, 1 is one number, 11 is another number. Don't find super intersection for this.
You'll understand what we mean. We should get a full point for that.
Which one?
I said if we just put 1, you'll understand what we mean.
I give you
Yeah,
extra
so we
credit.
could get full points.
Yeah, I give you extra credit. You're thinking too much.
Yeah. Too much work.
Too much intersection. All right, last homework question. Well, similar. So some of the homework questions are challenging, but the idea is this. So please don't ask me to solve, but you need to just
Can you go to the?
enjoy the pain. Rocio, yes?
Oh, can you go to the previous one?
Sure, Rocio.
Yeah, that one. Okay, awesome. Thank you.
So what is A union B? I'm fully confident that this time Musa can answer it, Adrian can answer it. Steven, you're hiding there.
Nope, I'm here.
You know, you used to come with the group G or group 4.
Oh, for that class, I'm done with it. So we're not in group anymore.
You done with the class or you're not?
Done with like that group. Like, wouldn't it be 1, 2, 3, 4, 5, 6, 7, 9, 15, 16, 17, 18, 19.
Your voice delaying, so I'm in the 7. Then you said.
Oh yeah, 7. Yeah, the 9, 9, then 15, then 17, 18, 19.
Did you say 217?
No. It's only 117.
I remember you said. Repeat. Okay, we don't repeat this. What was intersection?
Let's see. Would that be 3? 3, 17. 3 and 17.
All right. Is this correct?
Yes.
Is this correct?
No.
Sierra, is this correct for AB?
Well, doesn't the 3 come first? Because
Very
3.
nice.
Okay.
Very nice.
Oh, I didn't see you write it. I thought. Sorry, I didn't see you write it.
is super sensitive. 3,17 has to be same font as well. Don't. All right, guys. Whew. So this is a homework for tonight, tomorrow, and Wednesday. So I'm going to review. I'm going to go review what section 5.1. I'm assuming that you guys watched the video in 5.1 and 5.2. So we are dealing with normal distribution. Those are the type of graph that we work so far. So here, randomization and bootstrap distribution. So you need to know or have some reference that you should know what is a bootstrap distribution or what is randomization distribution. I have them here for you. We learned about bootstrap. Bootstrap distribution is a distribution of many bootstrap statistic. So what is bootstrap? Bootstrap sample is a random sample taken with replacement from the original sample of the same size as the original sample, okay? I mean, we love bootstrap. You should know everything about bootstrap. Then we learn about randomization distribution. A randomization distribution is a collection of a statistic from sample simulated, assuming the null hypothesis is true. All right. So now back to this randomization and bootstrap distribution. What do you notice on the graph?
They're all bell-shaped.
Bell-shaped, which is super important, all in bell shape. So this bell shape is a normal distribution. A symmetric bell-shaped curve we have seen for almost all of our distribution of a statistic is called normal distribution. Good. We have a theorem on this. Central limit theorem. For random sample with sufficiently large sample size, the distribution of many common sample statistic can be approximated with the normal distribution. The larger the sample size, the more normal distribution of statistic will be. Example. So this N means normal, mean, and standard deviation. For example, in this example, we have normal 0, 1. That means 0 is the mean and 1 is the standard deviation. So that's the graph. This is a graph. 0 is a mean and the standard deviation is 1. This is 1 standard deviation, 2 standard deviation, and 3 standard deviation. We learn in 3 standard deviation, we have 95% of our data. So let's have N2, 1. So N2, 1. 2 is the mean. So here is the mean. The center of the bell is the mean, X bar. And the standard deviation is 1. So we have 2 plus 1 is 3. 2 plus 2 is 4. And there's another one here. What we do in this section, in this chapter, we would like to move this one to make it to normalize it to 0 and 1. So this is here. And in this graph, we are having the same mean for all three graphs, but we are changing the standard deviation. So this one, standard deviation is 1. If a standard deviation gets larger than 1, so we're going to have wider bell. If it's less than 1, you're going to get this. Any question here? All right. Randomization distribution. If a randomization distribution is normally distributed, we can write it as n, a statistic, and a standard error. So we're talking about randomization distribution. We can write it as this. One quiz for you guys. If a randomization distribution is normally distributed, we can write it as n null value standard error, statistic standard error, or parameter standard error. Which one is correct?
So I have a quick, because I have it in my notes as statistic standard error, but when I did the video, it had it as null standard error, so I'm confused. I don't know if I have it wrong in my notes.
No, this is, so we just had this, if it's a randomization distribution, it will be a statistic and standard error. Because we had it right here.
Okay, so my notes are right.
Good. We have another question, which is null if you're talking about normal distribution. Nothing to do with randomization. But if you have randomization distribution, we are dealing with the statistic and standard error. So there are two similar questions, but one of them is randomization, another one is bootstrap.
Okay, that's probably what okay.
But anytime we're using randomization distribution, we are using this notation, not the null value and not the parameter, the statistic. Standardized data. Often we standardize the statistic to have the mean 0 and a standard deviation 1. How do we do this with this z-score? All right, so x minus mean over standard deviation or standard error. Standardized statistic. The standardized test statistic, also known as z-statistic. So that's the formula. Calculating the number of a standard error a statistic is from the null lets us assess extremely on the common scale. Well, so this is a formula. Let's move on to the next slide. So this is a beautiful bell-shaped standard normal. The mean is 0 and the standard deviation is 1. So it's 2 standard deviation and 3 standard deviation. The standard normal distribution is the normal distribution with the mean 0 and a standard deviation 1. That's the standard normal. So this is a null, and that's the standard deviation. standardized statistics are compared to the standard normal distribution. P-value, if a statistic is normally distributed under null hypothesis, the p-value can be calculated as a proportion of a as normal mean 0 and 1 bi. So this is, we find the statistic, we find the z score, and then we go to normal distribution graph. That's n 0 and 1. Then we find whatever z tells us. We find the area, and that's our p-value. Then if you have a p-value, we decide to reject or not reject the null hypothesis. The difference in proportions is 0.15, the example, and the standard error is 0.05. Is this significant? Is that yes or no? So we have standard error, it's 0.05. We have a statistic, we have 0.15. And how do we know is significant? We need to find the p-value, correct? How do we find the p-value? We need to find the z-score. So the formula for z-score was a statistic, which is 0.15 minus 0 divided by 0.05. We have a solution here. So let's follow the solution. So they used the z-score. They got 3. This is far out on the standard normal, so it would yield a low p-value. So z-score, so the z-score is 3. That means this is 3 here. We are looking for this much area, which is almost 0, correct? So for this reason, we will say it is significant. The answer is yes. If the p-value was large, we say no, but if its p-value is small, it will say significant. Any question here? Stephen? So now let's have some example. Find the specific areas for the standard normal distribution. So standard normal distribution will be 0, correct? 3 here, and 3 standard deviation there. When z is negative 0.8, so to find the area to the left of z negative 0.8. So we need, so even if they don't say this one, we need to know this negative is here. So if z is negative 0.8, what is this area? Manavir, how do we find it?
So do we pretty much plug in negative 0.8 equals, I'm not
I know, but what you're doing, you're going backward. You're going to use the Z formula. So a statistic minus, for example, mean divided by standard error. But now we have the Z, correct? What we do, we go to the computer and then we plug the Z. So you need to go to a stat key. Oh my God, where is that? Oh, those are here. So you go to a stat key, correct? Vertical distribution, you go normal distribution. So the mean is 0, we see, and standard deviation is 1. So that's a normal distribution. We learned that we're going to use this graph. So they said less than negative 0.8, correct?
Correct.
So it's going to be left. So we have 3 options: left, or 2 tails, or right.
It's going to be left.
It's going to be left. This is a Z-score. Use 0.025, the area of the red, and negative 1.96 is the Z-score. So if I change negative to negative, is that 0.8, like this? Oh, no.
I think it's 0.8.
0.8. So we don't have another dot. That's 0.8. So I change it to 0.8, correct, negative 0.8. The area is 2.2, 0.212. Good. So that's what they're asking. So the area is 2. So you need to use a stat key. There is a way to find through the table in the back of your book, but this is already done. So
if a Z-score is provided, you just go ahead and look it up in the stat key.
Very good. Yeah.
Okay.
So on this case, we got 2.12. Can you tell me what is B? Can you do the same thing? Tell me what is, if Z is 1.2. This is what we saw last Monday. I also sent you guys a document for all the solutions, I guess. But we need to be very strong on this concept for next section. Rocio, what you get for Z equal to 1.2?
I haven't solved it.
Okay, Manipur, what you get?
I got 0.115.
Very good. That's the answer. What about this one? Find the specific area for the standard normal distribution. That's the standard normal distribution. Mariana, this is N, 0, null, correct? And a standard deviation. The standard normal distribution, or just 1.
So we do this. So we do the same thing. Plug it into stat key, right?
Yeah, because we have Z, correct?
Correct.
The area to the right, so we have Z. But the question is, if we don't have Z, that's you're gonna see the next one. So if you plug it, what do we get?
0.0049.
0.0049. Do you think is this significant?
No. Wait. Trying to remember.
Significant. If it's less than 5%, it will be significant.
So yes.
This is good. Significant is less than 0.05. This is very small. which is good. We reject the null hypothesis.
Got it.
Correct. Yes, you have to just have that in your mind as why do we do this? What about z equal to negative 0.32, Manipur? Are you doing it in your phone?
Yeah, I have the stat key on my phone.
Does it work?
Yeah, it works, but it's just my fingers are too fat and I'm clicking on everything but what I need to click on.
So you said it for previous one, you were correct?
Yes, yeah.
What did you get?
Well, let me type it in. I had it on the right side, so it gave me a complete different answer. So that will be 0.093.
Good. Very good. So we are okay with the z. We got the z to find the area, and the area will give us the p-value. So 0.093. This is so far the best one. Let's see. Okay, let's do this one again. Firstborn child. So the question is, are firstborn child actually smarter? Any of you guys are firstborn child?
Nope, the middle child.
The only child.
So let's claim it that they are not smarter. So in order to say yes or no, in order to say yes or no, we need to, actually I think they're smarter. Firstborn child I think is smarter. I think so. Anyway, based on the sample of college students, we find, so they get the statistic here, 30.26 for the SAT. Then from the randomization distribution, we find the standard error is 37. So those are provided. What is the question? The question is, what is the standardized? Sometimes I can pronounce, sometimes I don't. Anyway, we are looking for the z value here. What is the standardized test statistic?
A.
A. Very good. How do we get A?
I did 30.26 minus the null, which is 0, divided by the standard error, 37.
But if here in this question, here they are asking us what is Z. So they're asking about the Z score.
Okay.
Z score.
Even though it's not saying straight up Z score, when it says standardized test
standardized test statistic, that's the Z score. Because we're gonna standardize the data, we're gonna move all the crazy. If the graph is here, for example, if the mean is, for example, is 15, we're gonna standardize this. We're gonna move this one to 0 and 1. That's the meaning of standardizing. We're gonna use n, 0, and 1. Good. So in order to do this, we have to get each point, apply a statistic minus null, which is 0 divided by standard error was 37.
Isn't null always going to be 0?
No, not always.
So how would we know if it's a different number than 0?
They give you the null, value of the null. They get value of H null.
Okay, so it'll say something along that line. So if it was 1, it would be like the 30.26 minus 1.
Yes.
Okay.
So here the null hypothesis, we are assuming that there is no difference. If there is no difference, it will be 0. That's why I put the value of null is 0. So the solution, I think, is the next slide. So a statistic minus value of null I know the meaning of null means 0 in computer, but we're not thinking that way. So this null is the value of the null hypothesis. So we get 0.818. So this is something around the x-axis. So then now read the next question. The standardized test statistic is 0.18. What is a p-value? So how do you find the p-value, Manipur?
Let me look at my screenshot really quick to find the p-value.
How do you find?
Oh, wait. Like, isn't that because we have the z-score, right?
Yes, this is.
And then we just put it. Okay, hold on.
We cannot wait longer. We have a solution. What did you get?
So much, yes, I got the same answer. So much me trying. I need to save it on my computer. My hands are too big for this. And it's hot in this house right now.
All right, too many statistics going on there. So this is a solution. So we have the z-score. We go to a stat key. And this is positive. You also need to know, is it left, right, or both sides? The question they ask, are they smarter? So are they more? So then you're going to look at the right side. You put 0.88, the area is 0.207. Is huge, correct? The p-value is big. So that means we do not reject the null hypothesis, but that's the sentence we're going to share. So if we do not have conveniencing evidence that the firstborn children are smarter. That's good.
So probably the middle child is the smart one. That's why.
If we have, you got the compliment. Good. You're applying the compliment. Set.
Exactly.
Reverse set, yeah. Let's do this question one more time, then we go. So that's a question that we don't use 0 for the z-score. So let's read the question. So, does this provide evidence that more than 60% of women view divorce as normally accepted? So this is going to be our alternative hypothesis. What are the null and alternative hypotheses? So we have H null and we have HA, correct? What is HA? What is alternative, Manipur?
That's going to be more than
0.6.
0.6, okay.
Right. What is the null hypothesis?
P is equal to 0.6.
Excellent. What is the test statistic? So here we are using the z-score. Good. So the formula for the z, we had the statistic minus null divided by a standard error. So this null is this one. It's a null hypothesis value. The null parameter. So we're going to have a statistic What is the statistic here?
0.67.
Excellent. This is the statistic. 0.67 minus 0.6 divided by standard error. What do we get? Ray, you're almost done. We have 3 more minutes. Adrienne, what'd you get?
Hold on. I got a negative.
Negative?
Yeah.
Why'd you get negative? Do it again. 0.67 is more than 0.6.
Oh wait, never mind. Never mind.
3.33.
Correct, Adrienne? 3.333?
Yes.
I don't know. I got a negative.
Still you get negative?
Yeah.
What type of, I don't want to say phone. You mean you're using phone or calculator?
No, I'm using the TI-84.
TI-84. Oh, okay. This is very important. I think you put 0.67 minus 0.6 divided by 0.021.
Right.
This should be in the parentheses. Don't do this mistake. This is very bad. So this you calculated, then
With the
divide it.
parentheses.
Correct?
All
Then
right.
when you type it, the computer do this division first. That's why you get negative.
All right. Thank you.
Very good. That was a good point. That please, if you're using the fancy calculator, so you have to know how to talk to computer. So you get 3.33. This is a z-score. So after you find the z-score, part C, use a normal distribution. Again, normal distribution. This is n, 0, 1, to find the p-value. What do we do now? We can ask our friend Manapir to use the smartphone.
No, I was jumping ahead. I thought I had the p-value, so I was gonna go
How
put
did
it in
you
the
get the p-value?
calculator.
How did you get the p-value?
No, I don't have it. I thought we
Yeah.
already. I thought to see. Oh yes.
You have to
Sorry.
see your favorite. You like, I mean, you just.
Louis. No, no. You can't keep on picking on me because then I'm gonna forget when it comes to actually knowing it. 3.333. Okay. It is 0.0. Oh my gosh. 0.0043.
So you need to make sure left, right. I think you randomly picked the right or left. I don't think you picked that. You were.
I picked
Well, you
no,
are
I did.
right.
I picked
You
the
are
right
right.
tail.
This is greater
Yeah.
than, so we're gonna look for this side.
Yes, it is. It's on the right side because it's a positive number. If it was a negative, then I have to click left.
Yeah, but I think somebody knocking the door. Okay, last one. What is the conclusion of the test? So when we have a p-value, now we have to make a conclusion. Here's a conclusion. So the p-value is super small, correct? Which is good. The p-value is very small, so we have a strong evidence that more than 60% of all women view divorce as morally acceptable. Is that true? Oh. It's difficult.
I'm gonna plead the fifth.
I'm with Mariana. I think I'm not going to say anything. Not that I'm married or anything, but.
You're with money, you said? Okay. Okay, guys. So please